Hello, welcome to the stream. I see we've got 9 people watching. Don't think anyone has chatted yet. If you are watching, drop me a message in chat. I see MK Ultra 360, thank you very much for the follow. So we're going to be doing some Portswigger Web Academy. We did this back on Monday, and it was a lot of fun. Back then, I basically let the viewers choose what we wanted to do. I'll do that again this time, but obviously, since there's nobody in chat as far as I can see, maybe we'll have to choose for you guys. If you want to see something specific in chat, see something specific on the stream, let me know in chat. Otherwise, we will just go ahead and I'll choose something random. We've got a ton of labs we can be doing. Let me proxy through burp. One thing that might be fun is doing request smuggling. That's always fun. It's kind of complicated. Hey, AMod22. First one. Welcome to the stream. First and only person in chat, so since you are, and there's nobody else, you have the honor of choosing what we do. Or you can just leave it up to me. But if you've ever done Portswigger Web Academy, you might be familiar with some of this stuff. However, if you're not, we go to the labs list, which I'm not entirely sure if all labs is the right place to click. Let's see. No, because there used to be a nice list. I'm guessing actually learning materials. Alright, we're going to learning materials. That at least has like a content page. Debarco, thanks for the follow. Alright, so here are all the learning materials. We did OAuth on Monday. That was a lot of fun. That was challenging, but a lot of fun. We've got host header attacks, business logic, web cache poisoning. That's slightly tricky, but we can have a go. SQL injection we've covered on a stream before, so probably not the best one to do. Cross-site scripting I don't think we've done. And there's a ton of different stuff on that. Cross-site request forgery, always good. Did XXE on a stream, but I guess we can do it again if people want to. Clickjacking I would not do on a stream. It's just the labs are kind of complicated for various reasons. Clickjacking itself is kind of complicated. Server-side request forgery. The request smuggling, like I said, that's kind of unique and kind of special. So that would be a good one to do. But otherwise, we've got OS command injection, template injection, deserialization, directory traversal. You do access control. So if you don't tell me in chat what you'd like to see, then I might just choose for you. Let's do request smuggling. Yeah, that's a good idea. All right, so I'm gonna have to load a specific plugin for this extension. Sorry, HTTP Request Smuggler. Just make sure it's the latest one. Yep. Okay, that's good. Okay. So, if you're not aware what HTTP request smuggling is, we will do a quick explainer. So let me just tell you what I'll do. We'll visit example.com in the browser, and that should have gone through burp. And let me just send it to repeater. All right. So this is a GET request. It doesn't have a body, so let's give it a body. So we'll change the request method, and we'll just do test equals test. So with a request in an HTTP request, if it has a body, the standard way of telling the server how many bytes are in the body is using the content length header. All right, so you see here we have a content length header which is set to 9, and like voila, there are 9 bytes in that body. All right, if we change this to test equals test A, that content length is going to get automatically changed to 10. So that's the standard way. That's like the default for pretty much everything that uses HTTP. However, there are 2 ways, in fact, of specifying the length of a body. The content length is the first. The second is using transfer encoding. So transfer encoding is kind of weird. I wonder if it shows a better example. Down here, probably doesn't. Right, yeah, this might explain a bit. The transfer encoding header can be used to specify that the message body uses chunked encoding. This means the message body contains one or more chunks of data. Each chunk consists of the chunk size in bytes expressed as a hexadecimal, followed by a new line, followed by the chunk contents. Okay, so in other words, if we wanted to convert this to chunked encoding, what we would do is we'd take out this header, and then so with transfer encoding chunked, and then let's go back. There were nine bytes here, right? And so 9 in hex is just 9. All right, and that's how we do it. So effectively, when a web server reads this, it's going to say, okay, well, it's chunk transfer encoding. This first chunk is 9 bytes long. There are the 9 bytes, right? And then it would go down to the next bit, and there's nothing there, so that's the end. So that might actually work if it supports chunked encoding. I'm not sure. Example.com probably doesn't. All right. Oh, hang on. It set the content length as well, so we need to tell it not to set that. But it doesn't. But that's a valid request still. It's exactly the same request. The 9 is just in the body instead. So that's kind of interesting. So where does HTTP request smuggling come in? This comes in when you have more than one server at the back end that processes the requests. Okay, and this is actually relatively common nowadays. In fact, it was extremely common because you'll have potentially the first thing it will hit is either a load balancer or some kind of firewall device or an IDS. So that's the first thing, and that might process the request, and then potentially it could go for a reverse proxy, and then finally make its way to the actual web server, right? And if those all process the content length header and just ignore the transfer encoding, that will be fine. However, all of these servers usually use different software, and they usually have different rules for what to do. The default, you're not supposed to actually specify both of these headers. You're only supposed to specify one. That's what the spec says. The spec, I believe, also says if you specify both, that the server should obey the content length and not the transfer encoding. However, as we all know, with standards, nobody follows them. So you get to the point where you have servers which will accept both of these and they'll favor one over the other. And you also get to the point where servers that don't accept transfer encoding necessarily or have it weirdly blacklisted, you might be able to get around a blacklist somehow. So what happens when you have two servers handling these requests in different ways? Well, if you have a server which handles the content length, and then you have another server that handles transfer encoding first, you can smuggle a request within the first request. And so I think this is what this one's doing. Right. So in this case, the front-end server is going to process this entire request because it's respecting the content length of 43. So it says, okay, this is all one request. It sends it through to the back-end server, which favors transfer encoding chunked. The transfer encoding chunked says, okay, there's actually 0 bytes in this body, so this is the end of the request. All right, but then it has this next thing, and it interprets this as a separate request because this request told it there was nothing. All right, this request said I'm ending right here, and then it got a new stream of bytes. And because obviously with HTTP 1.1 anyway, you can send multiple requests through the same connection. This could just be two valid requests coming in at the same time. So effectively what happens is we make this post request, which was the original request here, but then a second request gets through, which is the get request. Does that make sense? And so you can smuggle a request through in one request effectively. So there's some diagrams about how that happens, but it's probably easier to show it. So what we'll do is let's open this lab. It's important to note as well, actually, before I do this, that the smuggled request, if you just send headers and no body, which in this case you are, this is going to get appended to whatever the next request comes in. So in this case, right, it's just a get/admin HTTP 1.1 with a header foo x, right, and then literally nothing after it, no new line or anything. So this would get appended to whatever the next valid request is. And so it would actually change that request into something else. So I'm guessing maybe I can do an example. Okay, so let's say that you have a perfectly valid request, which is just a GET request, right, to example.com. Okay, so this request is perfectly normal. However, if I'm able to smuggle in before this request, right, if I'm able to smuggle in this, So /admin HTTP 1.1, and then the next line foo x, right? Suddenly this is fine because the server is going to ignore this line, right? And so the request becomes a GET request to /admin on HTTP 1.1, same host, same everything. Okay, which might not seem like a big deal, but imagine that there are cookies here, right? And imagine that this user that we've smuggled this request onto is authenticated as an admin, right? Then potentially we can fake a request to the admin site and it will be authenticated. So that's important to note as well. So let's do this. So this is a lab involves a front end and back end server. The front end server doesn't support chunk encoding, so the front end server supports content length. If you see classifications of request smuggling, they usually classify that this either cl.te or te.cl or even te.te. And basically all that means is cl.te means content length is supported by the front end server and transfer encoding is supported by the backend server. If it's reversed, then obviously the reverse is true. And we'll get on to te.te. That's slightly different. But to solve a lab, smuggle a request to the backend server, so the next request processed by the backend server appears to use the method gpost. All right, well, how would we do that? Well, imagine again we have this post request. So we're going to send a post request after we've smuggled our request. So let's just imagine there was a post request. Okay, if we're able to smuggle a request here and smuggle it so that we put a G in front of this post here, then this separate request here will go through to the backend server as gpost, which is obviously going to cause an error. So what we'll do though, we need to find I need to add we're going to add this as the scope. Yep, we'll drop all those. Okay. So the first thing we'll do is we'll send this to repeater. We'll change it to a post request. And we'll just do x equals x. Okay, that gives a 200. So what we should be able to do is launch a smuggle probe. And I think that should all be good. So we'll launch that and we'll see if that comes back. Sometimes the request smuggler does not work very well. What we can do though is use repeater itself. You know, I'm just going to wait for that to run. So the output for request smuggler comes here, so it's queued the attacks, and it's, if you go to logger, you can see it basically launching it all. So it's basically trying a bunch of stuff. Invalid request head. I guess we could try and calculate. What we really want to do is set the content length to, hang on. Okay. So what we'll do, we'll set transfer encoding to chunked here. Oh, actually, scratch that, it found it. All right, so you see it found it here. Possible HTTP request smuggling. So we got an internal server error when it sent this. So what we can do is right click and do a smuggle attack, and that's going to launch Turbo Intruder. Okay. Hopefully it's finished. Let me just make sure it's finished. Okay, it hasn't, but we can set up Turbo Intruder anyway. So what you can do with Turbo Intruder, you can add the prefix, and the prefix was to solve the lab, we need to make the backends appear to use the method gpost. So in this case, all we should be able to do is set, I think, just the prefix of G, all right? And that should get prepended to one of the requests we're going to send downstream, and hopefully, if we're quick enough, it should respond with gpost. Let's just launch it and see what happens. Yeah. Okay. So that's what happened. We effectively, what Turbo Intruder does, it just sends very rapid requests. So it's going to send the payload effectively in the first request. So this payload sets up transfer encoding. So you see you have 3 bytes there, 0 bytes there, and then a G. Okay, and the content length is 14. So it's going to send, the first server is going to parse this, and it's going to think, okay, this content length 14. All right, the 14 will go, I think, all the way to here, right? The second server is going to receive this. Sorry, no, 14 will cover everything. The second server is going to receive the transfer encoding chunked header, and it's going to say, okay, well, transfer encoding means there's going to be 3 bytes, there they are, and then there's going to be a chunk of 0 bytes, there it is, right there. So this is the request. So it assumes that this G here is part of the next request, and the next request that comes in is going to be this one. So basically, Turbo Intruder sends requests 1 through 14 effectively instantaneously at the same time. So they will not arrive necessarily in order. So it turns out this request, number 2, arrived directly after this one, 0. And this is still a post request, right? So the G from here was appended here. And it was processed by the second server, which then said, oh, okay, this is a method gpost. Does that make sense to everyone? I understand request smuggling is kind of tricky. But hopefully that explains exactly what happened. And why we use Turbo Intruder is effectively because we want to actually we want to be the victim here. In a regular request smuggling attack, you don't really necessarily care about who the victim is. For the purposes of this demo, we want to be the victim. So the reason we send 14 requests instantaneously after the payload is we want to maximize the chances that one of these requests is processed directly after our payload. Obviously, in real world pen testing, that's harder because if you're going against a live site, there's going to be thousands potentially of requests coming in at the same time. But if you're testing like against like a staging environment, this is going to be way easier to perform. Pragnio and Godemendola, thanks for the follow. So I think this solved, yeah, it solved the lab. Good. Okay. That was that one. So the next one is a basic transfer encoding followed by a content length vulnerability. So this is the reverse. But we want the same thing. We want to just use gpost, right? So what we'll do again, we'll quit this, we'll use burp. We'll make this a post request. So the reason we make it a post request is obviously get requests you can't smuggle, you can't put anything really in the body because get requests by default don't have bodies. There is actually a kind of interesting attack where servers process the bodies of get requests even though they're not supposed to. But since most servers don't do that, we're going to add a body by changing it to a post request. And we're just going to do x equals x. All right, and then we're going to launch a smuggle probe. I wonder if we can just... the annoying thing is it sends all of these. I guess we can increase the thread pool size maybe. But we'll do that. We can also just try it manually. Manually is really annoying. So let's try it manually for... Oh, hang on. For the manual stuff, what you need to do is the content length is just going to be this plus the new line. Okay, so effectively what it's going to do, if we set this as 8 smuggled 0, turn this on to make sure there's, we need 2 of those. Okay, the content length is going to be 3. So we see that goes through. So we might need to do it, might just send it in quick succession. Nope. I think potentially because I got this thing running still. Alright, did it find it? Not yet. But effectively what's going to happen with this one, you have... Oh, I didn't even set the transfer encode, and that's why. Chunked. Hang on. Okay, there we go. So did you see what happened there? So I forgot to set the transfer encoding. So in this one, the first server is going to see the chunked header. So it's going to say, okay, let's look at this chunked encoding. It means that there's going to be 8 bytes, which are here. And then there's going to be these 0 bytes, right? So it's going to send everything to... no, wait a minute. Hang on. Right. Yeah, sorry, I got confused. So the first server sends everything through to the second server again. The second server looks at the content length and sees it as a content length of 3. And that content length of 3 is literally these 3 characters here, right? The 8, the carriage return and the new line. And so that's all it thinks is the request. This is all the request, right, that the second server sees. It thinks anything else is from the next request. And so that's why we can get this smuggled value attached. Which is why when I submitted it, we got this 200, and I submitted it instantly again, and we get an unrecognized method smuggled 0 post. Okay. So in this case, I think we can actually just remove. I think we can remove all of that and send it through twice again. Oh, maybe not. This has found it anyway. Right, so there has to be a 0, I think. There has to be 2 of those. So if I just put a G here. Potentially screwed up. This is the other problem with this, is you can quite easily screw it up. Well, let's try just doing it with Turbo Intruder. So again, Turbo Intruder, so since we found it using the extension, we can just right click and open it up. This is the Turbo Intruder code for transfer encoding first, followed by content length. So again, we just need to do, if we put a G post here, we want to actually put the entire request in. So we want to copy this, because we don't just want to append stuff, we want to actually do the entire request. So what we'll do is we'll do G post to the host, and hopefully if we use the attack, there we go. Nope. New lines and headers not allowed. Let's configure it again then, hang on. I do wonder if I've just killed the handling of the server. Yeah. Oh, okay, it could be up again. Let's try it again. So we want to do G post attack. Why is that error? I'm honestly not sure what's going on there, because that should... It's definitely smuggling it, because this request, this one request here makes no sense given all these. I'm just not entirely sure why it's saying there's new lines. I'm guessing what I could do. Let's just try setting it to G and see what happens. Okay, that kind of worked. But obviously it's G followed by a 0 because this is all going to get processed at once. So we do need to do G post / 1.1. Then I'll just put X. So that should cancel out the next line. So let's try that. This is probably going to work, hopefully. Let me run it again. Invalid request. Hasn't solved it yet, so that is weird. I wonder if I do. Has it broken again? No. We may have to move on to the next one because this one is really weird. I'm just gonna, I mean, this worked, right? So, gateway timeout. Oh, okay, because it tried to get here. Thank you, Xcoding, for the follow. Alright, tell you what, let's see what their solution is. Because doesn't honestly look. What if I don't have Bet Pro? That's a good question. There are a few scripts. Technically, Turbo Intruder is free. You can use it in Burp Community Edition. So that might work. It's saying you could just, I guess, take out all of that. Is that going to work? Okay. That worked. I guess it didn't like the host header. As soon as we take out the host header, it worked. But it's slightly weird. But that solved it. Yeah. But effectively, what's happening with this one is we can smuggle an entire request through, right? So we're not necessarily just appending. We are appending to another request, but we're actually putting that request in the body, if that makes sense. So remember here where oops, what did I do? Crap. Okay. Remember here where we were able to append a single character to everything, and then the request got sent through properly. So in this case, we can still do that, but what we did this time is we appended an entire request, right? One blah blah blah, and effectively then put the actual request that's getting appended to effectively just goes into the body of this request now. So this all becomes the body. And that's going to come out. That can actually be useful if you can basically smuggle a request where the contents of the body get saved somehow. You can actually save cookies of another user, for instance. So that's kind of an interesting way of doing it. But let's look at a few more. Oh, right. That did get solved. Alright. So this is the third kind, which is the te.te. So this is where both front-end and back-end servers support transfer encoding. But you can basically tell one of them not to process it by obfuscating the header. So for instance, adding an X to the word chunked. Some servers will still read that as chunked, some servers won't, and then they'll default to the content length. Adding a space after the transfer encoding header key itself. What else is there? Using two headers, using a tab instead of a space, using a space in front of the header. There's basically tons of these. So this one you definitely have to use the Request Smuggler extension because it knows all of the different types. All right, let's do this. We'll change request method again. Just do x equals x again, just to have something in there. And then we'll launch a smuggle probe. This is basically, by the way, what all of these are. These permute things are effectively different ways to put the transfer encoding header in. So let's launch that. But what we'll do is we'll go back to this. You see how this was the last one. We used the vanilla because that was it's just the one where you have transfer encoding chunked, right? A simple header. However, there's obviously the server can be vulnerable to multiple different transfer encoding header types, I guess you could say. So in this case, the no space is just basically having no space between the colon and chunked. So all this is saying is that the server that processed the transfer encoding recognized this as valid. That's fine. That makes sense. The space isn't necessarily required, right? Multi-case. So in this case, it was just setting the first character of transfer encoding as a lowercase t and the rest of it as uppercase. Connection. Okay, so I guess that's just setting a connection header transfer encoding, but yeah, that makes sense because transfer encoding is still there. Value prefix 1, which is, I'm guessing, it looks like there's two spaces there, I think. Yeah. So basically just putting two spaces in front of chunked instead of one. Prefix 1 is, honestly, that looks exactly the same. Oh, is there something after it maybe? No. I'm not sure the difference between those two, but they look identical to me. And oh, a fixed space. Okay, right. So I guess that's a different. Right, that's a tab. Okay, makes sense. All right, so that in that case they put a tab before the chunked. So here we go. We have a possible HTTP request smuggling on this new one where they have put transfer encoding chunked, transfer encoding identity, okay? And so one of these servers has effectively said, okay, well, since there's the identity string there, it's not using transfer encoding, so I'm going to respect the content length. And the other server is saying, okay, well, transfer encoding is chunked, so I'm going to use that. So I think the solution is the same, right? Hey MajSec or MajKsec, thanks for the follow. Yeah, Ang3LD, he's a regular on the streams. That's great that he sent you. Okay, let's try and do this one. So this should be exactly the same. So we're gonna smuggle attack TECL. Even though it's technically TETE, we're going to use the TECL. We're going to do exactly the same thing. We're going to change that to gpost. I guess we're just going to remove the host header because that seemed to trip us up last time. Let's see what happens. Yeah, okay. It's weird that the host header tripped us up both times. I wonder what happens if we just... I'm just going to put the host header in again and see. Is there anything... okay. Attack. Yeah. I'm honestly not sure why it's doing that. But there we go, it worked. We were able to smuggle in G-Post. Kichiko, thanks for the follow. Neckforce, thanks for the follow. Hey Mod, you followed 3 minutes ago. Thank you. Okay. So that should have solved it. Did it solve it? Yes. Okay. This I think is the same thing. Two servers handle duplicate HTTP. Right. Oh, the front end server rejects requests that aren't using the get or post method. Well, that's okay. Okay. That's weird. How did I solve that lab? Was it the same one? Oh, it was. I must have scrolled up too far. All right, let's go on because there's a few more. Confirming a CLT vulnerability via differential responses. Okay. Hey, Ang31D. Nice to see you. How many streams is that in a row that you've been to? I feel like it's a lot. Granted, I have been streaming every day this week, but... Nah, you were here yesterday. You must have been. I feel like you've been on every stream this week. Which is great. Thank you. I don't know why, but I just love this. I know these are all like weird blog posts, but I just love this one because it looks so weird. I heard they got rid of the Pog avatar, right? On Twitch. Something like that. Alright, let's see. This is a CLTE. So I guess let's try doing it manually because this would be interesting. So let's first grab this request, send it to repeater, turn it into a post request, do x equals x, make sure that the content length is enabled. Alright, so we do get something. Okay. The request normally receives an HTTP response with status code 200. Okay, yeah, it does. Perfect. Alright, so the attack we're going to do, obviously we need to add the transfer encoding. So we'll do that first. And then we need to calculate effectively like how many bytes are in our regular message. And that's going to be 3, right? And then we want a 0 byte chunk. And then we want our get message, right? Our get 404. Because how we solve this is we want the next request to be for a 404. All right. And so, yeah, we should just be able to do get slash 404. Because I'm assuming 404 doesn't exist, right? And then we'll just do, I can just do foo. We'll just do foo. X. And if this works, if I open a new sorry, if I open a new tab and repeater, this works. What I'll do is if I send this request first and then send this request, this should return a 404 if it works. Let's see. It does. Perfect. Is this vulnerability common? Not too common these days. It was found a lot when it was first sort of yeah. So but when it first came out like 2 years ago, the guy who discovered it basically went around I think like the top 200 biggest sites that it was on and like told them about it, and they all patched pretty quick. It's also it's extremely difficult to find if you're using one of the more well-known cloud infrastructure providers. Like you won't find this in AWS or Azure. They've pretty much patched everything that could possibly happen. Having said that, it's still definitely out there. It usually just depends on the setup. All the big sites have been patched, so you may find some of the small sites. There's definitely bug bounties that still get found because of this. Yeah, it was James Kettle who found it. If there's any really cool web vulnerability that's discovered in the past like 5 years, there's like almost a 50% chance that it was James Kettle who found it. The guy is like a legend. James Kettle is like he's the director of research for Portswigger, the guys who make Burp and the guys who make this web security lab. So yeah, director at research at the place that develops Burp. He knows his stuff. So right, okay, so I mean we solved this one, right? Does everyone understand how we did that manually, right? So let's actually, since we got it manually, let's just go back over what we did, because it's just, I think it's just easier to do, right? So effectively, what happened was we sent this request first. I'll open a new one, and for the sake of argument, I'm just to make it easier to show, I'm just gonna delete all of this, right? So this request got sent to the web application server, and let's imagine we're a web application server, right? And we're just receiving streams of bytes, and they're all getting concatenated together, okay? Because that's basically what's happening. We're receiving streams of bytes. So we received these two requests. And again, just for the sake of argument, I'm going to remove... Let's just remove this, I guess. Now, usually if a server receives these two requests in a row, it understands what's going on, right? Because content length is here. All right. So content length, if you obey content length, you know that there's 38 bytes in the body. So the body starts here, and we count 38 down, right? And so we get all, and obviously new lines are counted. So there's some hidden stuff here. There's technically a /r/n here, right? You can see that if I turn on here, okay? So 38 bytes is from here all the way to here. All right. So the first web server understands that this is all one request. All right. This is the body of that one request. Okay. And so these are two separate requests here. But so it's going to send this entire thing through to the second server, the second backend server, right? Okay, including line 12. Until the so basically it includes everything I'm highlighting, right? The first server understands that this is the first request. right? And this is the second request. And it understands that because it understands that this content length, 38 bytes means 38 bytes from here, from the start of line 7. And so you just count, right? So you got 1, then technically 2, 3, 4, 5, 6, 7, 8 for the new line. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, blah, blah. So you get down to here, right? So it's going to separate, and it's going to send this, though, to the backend server. But the backend server says, okay, I don't care about content length. There's a chunk header here. All right. And so it takes this stream, the same stream of bytes. It's been given all of this, right? It says, okay, chunked encoding. So this body is separated into chunks of data. The first chunk is 3 bytes. Okay, let's count 3 bytes. There's 1, 2, 3 right there. Okay, that's our first chunk. All right, it doesn't count new lines. New lines are irrelevant. The second chunk is 0 bytes. Okay, that's cool, I guess. There's 0 bytes. So the second server, the backend server, thinks that this is the first request. This entire thing, from the empty line 10 all the way up here. This is the first request. Even though the front-end server sent this stuff as well, right? But it doesn't. The second server doesn't know it sent that because all it's dealing with is a massive stream of bytes. Just think it's a huge stream of bytes. They're all concatenated together. And so the second server thinks, okay, well, this is the first request. Great, I'll send that on, and we'll process that. Give me the next bit of the request, please. So then it reads from its stream of bytes, and it reads this, and it gets this get 404. Okay. And then the next line is the foo, the header we sent with the X, right? But then what happens after, and because we didn't send a new line, right? This is still the same line. Still, basically, we've appended. We prepended to this valid request that some other person has sent. All right, and so it'll read this get. It'll read all the way down here. Because it's a GET request, it doesn't have a content length. So how web servers process GET requests, if they read GET, they'll say, okay, we'll go until we get 2 new lines in a row. Okay, and that's effectively just how it processes it, right? If you the first new line here, technically up here, we'll say that's the end of the headers, and then when you get an empty line, that basically means, okay, empty line, no body, because a GET request doesn't have a body. So the second server will accept this entire request as valid, even though it's technically the last bit of the previous request prepended onto a completely valid separate request. All right, and when it processes this, it doesn't matter that there's a GET request hidden in here because it's technically just part of this foo header, which is meaningless. It's going to scrap that. It's going to basically say, I don't understand what the foo header is. Right? That's just a random header. And so it's going to completely ignore this. And instead, it's going to say, okay, well, this is a get to /404. The host is there. The connection's there. Everything's there. So it's going to process that. And it's going to actually do a get request to 404. Which is why, even though we did a get request here to just the root page, which is valid, right? There's a get request to root, which ended up in a 200. Because this was smuggled, it actually ended up being a GET request to the 404. Does that make sense to everyone? I think it's way easier to explain it using a text editor. Why do I need this request? In the foo line? I didn't. So remember what we sent was this. We sent get /404 HTTP 1.1 and then we put a foo header and we didn't put a new line here. Okay? So this was what I sent as my attacker, right? And then this is what I sent as my victim. So imagine that these requests were sent by separate people. I send this one as my attacker, and this one as my victim. So this GET request here, this entire thing actually, is my victim's request. But because of HTTP request smuggling, it's actually my GET request here that gets executed. And so the GET request in here isn't, I don't need this. This foo line, right, is just to hide the GET request, because I know that this is going to get appended, or sorry, prepended to the next valid request that the server gets. And so I want to hide this GET so it's not processed. All right. Maybe another way to look at it is if I were to just scrap all of this and put X there, right? Just an X. So I'll send this request, and then I'll send this GET request again. Okay. I need to do access the lab again. It timed out. Okay. I'm just going to edit these bits. Okay. Sorry. Okay, and all right, this should work now. So I sent that, and I sent that, and that didn't work. Did I do something wrong? Maybe it doesn't work on this one. So on the first one, if we go back, we were able to get like a G post thing. Let's do this one again. Okay. We'll send this one to repeater. We'll send it to repeater again. So this will be our victim. I'll put that up there. Victim. And this will be attacker. And we will change the request method to a post. Do x equals x. And then we'll just copy. So we want transfer encoding chunked. We want that to be 3 bytes because there's 3 bytes, 0 bytes, and then an X I think should be, yeah. So I think if everything goes well, yeah. So you see we get unrecognized method X get. Okay. So again, let's make this simple. We'll run it again. I'm going to delete all of this. So just the stuff that we care about is here. All right. I'll turn off that. Who just followed? Okay, cat. I love the name. Okay, so again, let's paste this. We sent this first as our attacker, and then our victim immediately afterwards sent this request. Okay. So what happened was the first server, because remember there's 2 servers in this setup. There's the front end server and the back end server. The front end server respects the content length. It says, okay, there's 14 bytes. And it starts counting. And the 14 bytes go from here all the way to here. Okay? And so the front-end server thinks that this is all one request. Okay? And the back-end server thinks that the backend server says, okay, there's chunked encoding, so I'm going to ignore this content length. The chunked encoding is there's 3 bytes, there's the 3, and then there's 0 bytes, there's 0, and then there's nothing else. So the backend server thinks that this is all one request. All right, and so the backend server is going to process this as one request, and that was what we got back here. All right, we got a 200 OK. Because it just posted some stuff. And then it's going to process this. And this X is what we smuggled. From post to X, is that 14 bytes? Not from post to X. Content length is the body itself. Okay? Only the body. So the way HTTP requests are processed, you read them line by line, right? And so in this case, it's going to read the first line. It's going to say this is a post request. Okay, and then it's going to read all the lines until it gets to an empty line, which is line 7. Once you get to an empty line, the web server knows, okay, that's all the headers. All right, and so it then evaluates all of the headers and says, okay, was there a content length in there? Yes, there was. What was the value of content length? 14. Okay, so after this new line, there should be 14 bytes, and that's the body. And so this is 14 bytes. And remember, they're including new lines, right? And the new lines are effectively 2 bytes each. There are a /r and a /n. It's easier if I enable new line read here. So as you can see, got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah? If you count all of these, including the /r/n's, you get 14. So, Ang, does that answer your question? Why we had the second GET request? It's technically not, it's just being hidden. We're smuggling this X through. So the victim, we're smuggling an X here. Alright? Cool. Good to know. And obviously, if we resend it, we get 200. And it's the same thing if we just put an X right here, right? We get... oh, okay, actually, the front-end server responds to that. So we actually smuggled it past the front-end server. But it's effectively the same thing as sending XGET to the back-end server. Cool. This is advanced stuff, by the way. If you're struggling to follow along, do not worry. This is really advanced, so I don't. Even if you're following a little bit, that's great. Before it was patched, how long would this attack go on? As in, would the next X number of users end up being? Nope, just one. So, this request only gets smuggled once. So, it's only the next request that gets smuggled. After that, everything works out. So, in order to attack, for the attacker, they'd have to keep smuggling requests. However, like, there are some real-world applications to this. So, imagine that instead of, like, smuggling an X is just gonna cause an error, right? Which an attacker doesn't really necessarily need to do. But imagine that instead an attacker was able to smuggle an entire GET request, all right? And they knew, or they hoped, that there was an admin who was logged in, right? And imagine that the GET request, the backend server read the host name, read the host header. So let's give an example, I guess. So imagine we smuggled this, right? Host evil.com, and then we had that foo header X. Okay. Imagine we smuggled this. Okay. So what's going to happen? Well, and let's imagine also that we had cookies, right? The cookie header or something, okay? Teats. All right, tests. So imagine that we had a user who was logged in, okay, and we smuggled this in. Now there's two host headers, so who knows what happens when you have two host headers. But say that the backend server respected the first host header. Okay. Well, now you have a GET request to evil.com, which you own, and the backend server is going to make that connection, and it's going to send the cookies of this logged in user. Okay. So you can just sit on evil.com with a listener, and you send your attacker payload, right? And the very next user who's authenticated, their cookie is going to get sent to your server as part of the headers. And then you can just do a replay attack. All right. So that's a pretty serious impact. I'm not entirely sure it'll work here. I guess we can try it. We can create a payload and see what happens. Duplicate header, yeah, so duplicate header names are not allowed. So I guess the other way of doing that would be if we put in a content length. We would have to guess the content length, that's the problem. I think there is a lab that does this actually, but let's say we did content length 100 and no guarantee this is going to work. Okay. But it would have. We got DNS hit. So actually, yeah, that was going to work, guys. The only thing stopping it is that obviously there's some kind of firewall preventing connections to port 80 from this server. But effectively what I did there was I just smuggled this ATAR request in. And so let's view it again. Let's copy it. So we'll copy it on top of this one. So again, the front-end server is going to think that all of this is one request, which is fine. The back-end server is going to think that all of this is one request. And it's going to process this entire thing as a request. And it says a content length 100, right? So remember how it processes requests. It reads line by line until it reaches a blank line. Okay. Well, I'm going over the impact of it now, right? So it's going over the entire thing until it reaches a blank line, and then it says, okay, well, there's a content length of 100, so it's going to grab the next 100 characters, all right, and send that as the body. So actually, I should probably put post. Let's see if a post will work. I don't think it will. Yeah, it won't. But you can see what I got. I got the site to try and connect to my own site, right? This is evil.com effectively. I could just put evil.com in there. Okay, so I'll send that. There we go. Server gateway timeout connecting to evil.com. I'm making the backend server try to connect to evil.com, and it's going to send this request to me, right? And this request could contain cookies. Like I said, I think there is a lab in here. Could you access 403 files? Probably not. This isn't like local stuff. This is still evaluating HTTP requests the same way. I think there is, and I'm gonna have to see. capturing other users' requests. This is the one I'm talking about. Okay, so in this case, it looks like we're smuggling a post to a comment. I wonder if there's one that uses an external site. I'm not sure, actually. It would be interesting to see. I'm actually gonna go to all the labs and see if there's one that's named that. But it depends what the 403 is for. Like if there's a user who can access a 403 as a 200, right? Then potentially, if you're able to smuggle a request on top of theirs, could you use smuggling to poison someone else's response? I don't think so. Not responses. It's request smuggling rather than response smuggling. Yeah, so there isn't. The only lab there is this one. So I think I always give this one a go. I'm not entirely sure how easy it's going to be. But we can try it. This one is, yeah, this one's going to operate in a weird way. Basically, there's a comment field here. So if we post a comment, so we'll go to repeater. So what we want to do is we want to smuggle. Oh, that's not the one. It's this one here. We want to smuggle a request. We want to force the user, right, to post a comment where the comment is their HTTP request, if that makes sense. So let's try it. What we can do, we need to move all this stuff to here. That's going to be there. So we will need to change this into a post request. Transfer encoding chunked. So again, we'll have x equals x, 0. And then we want to do a post to this. Using our session cookie, because that's what we want. What else do we need? We need to tell it to use application encoding, and a content length. Okay, connection closed, that's fine. But then what we're going to do is we're going to set this content length to something like, let's set it to 300. Okay. So we know that there's 121 characters in this body, right? But we're going to be appending this request here onto someone else's. So there's going to be more than that. So we want to try and do this. So I'm wondering, what I'm going to try and do is do it myself. No guarantee this is going to work, by the way. So what I'll do is we'll submit this, and then we'll send that. That looks like it worked. All right. So let's go back to the blog. There we go. You see that? So in that case, I was playing attacker and victim again, right? So as an attacker, I sent this smuggled request. This is just a post request to /, all right? It's not going to do anything, okay? But I smuggled this other post request, which makes a comment, okay, as my user, by the way, because it's using my session. But the comment was blank, all right? But what happened was, and again, I'm going to copy this into here. So this was the thing that got sent through. Just for the sake of clearing everything up, I'm going to remove like all these weird headers, right? So that was sent as the attacker. And then as a victim, I just visited the root of the site. And so as the root user, sorry, that's not the root user, with the root of the site, my request gets appended, remember, to the byte stream. This is just byte streams. So the first server is going to look, and it's going to say, okay, it's a post request, reading it. Okay, it's got 365 content length, which goes all the way to there. Okay, that's valid. That's a fine request. It's going to send that through to the second server. The second server, the backend server, is going to look at it. Oh, Superhero 1 is raiding. Nice. I think that's my first raid. Hey man, how are you? Thank you for the raid. So the second server, right, is going to say, okay, it's got a chunked header, transfer encoding chunk. So I'm going to ignore this 365 business. This is weird. So it's going to read the chunks. The first chunk is 3 bytes. There they are. The second chunk is 0 bytes. There it is. That's it. That's the entire request, it thinks. So the next request it processes is this one. And this is a post request to /post/comment with a content length of 300. Okay, so then it starts just counting. And so 300, right, we know this was, all the way here was, what, 121 or something? Well, that's not all of it. So 300 goes all the way down here. Okay. So let's do it again. Let's increase the content length with smuggling here. Yeah, front-end server uses content length, back-end server uses chunks. So let's increase the content length to 500. Let's go crazy. All right, and let's, here, this was unauthenticated. Instead, let's put a cookie value up here, right? Cookie, hang on. What's my cookie actually? Okay, cookie, super secret cookie equals I am an admin. All right. Okay. So that's my super secret cookie. I'm playing the victim here, right? But all right. So we're gonna send this again. Maybe 500 is too much. I don't know how many. I'm not sure how many bytes are in this. Okay. Maybe that was a bit too much. I'll put it to 300. Screw it. 300 is doing it. So I'm going to send this as the attacker. Okay. And then instantly I'm going to send this. Okay, that didn't work. Let's send it again. That worked. You see, we got a post comment confirmation. Even though I'm just visiting the page. That's all I'm doing as my victim. I'm just visiting the root of the server. Thank you for all the follows, by the way. I'll go over you guys' names in a minute. Okay, so let's view. This was an invalid request. Does anyone know why this is invalid, by the way? The fact I just reloaded the page. Anyone understand why? So you're close, Ang. Think about it, right? I asked the backend server, right, thinks this is a completely separate request, right? And it's because there's no transfer encoding chunked, it's going to use the content length 300. I just set it to 300 randomly. Okay, so it's going to count 300 here. So this goes down to say it goes down to here, right? Say that's 300. Okay, so the backend server thinks that this is one request, right? So it's going to process that, which means the backend server now thinks the next request that it's going to process is this, and this isn't valid, right? If you send image/webp, comma image/apng to a web server as a whole request, it's going to say what? So this error, right, is from this request. It thinks we've sent this request, which we haven't. So we've technically request smuggled ourselves twice. So if I press enter again, it's going to clear it out. And there we go. Look at that. We have the super secret cookie value. Okay. Remember, we're browsing the site as the attacker. All right. So for those who are asking about impact, this is an impact. How would you fetch it secretly? A good question. Imagine that instead. So remember this, because this we smuggled our own cookie, our attacker's cookie, right? Because this is us. Because we smuggled our attacker's cookie. Imagine that this site, when you log in, has like an inbox functionality where you can create draft emails, for instance. Like imagine that was a thing. You could, instead of making a comment, you could just create a draft email. Or a draft direct message, or whatever you want to call it. And put the body as whatever this is. And so then, what's happening is the victim is basically being forced to save their HTTP request as one of your draft emails. The other way of doing it is the one we said before, right? Where we change the host name and we put it to our site. This doesn't work in this lab. I'm not entirely sure why they don't have a lab that doesn't do that. But yeah, in this case it doesn't. So yeah, that's why there's multiple ways you could fetch it secretly. The easiest would just be to change the host header to evil.com and create a listener on evil.com and just watch as all the packets come in. Okay, let's go through. Thanks everyone for the raid. That was nice. That's the first time that's happened. So who have we got? We've got Superhero 1 who did the raid. Thank you very much. We've got Lord Naberius. Yeah, first raid. Look at that. Nice. We have Superhero 1 again has followed as well. Not only did he raid, he followed. Tresuave, I'm guessing is how you pronounce that. Trax 3. OX Doggy. Anonymous Faith. And, oh my goodness, Elban Doloro Dondevoy. I'm going to guess is how you pronounce that. Thank you. Thank you for the follow. Is there anyone, because I understand the raid sort of happened in the middle of this, is there anyone who doesn't understand what is going on? what we're doing? We're stealing requests with HTTP request smuggling. Is there anyone who thinks that this isn't an impact? Because this is definitely an impact. Look, I have the super secret cookie. Thank you. Okay. Yeah, I honestly I haven't really explained it like this using a notepad before, but I honestly think this is I mean, correct me if I'm wrong, anyone. If this needlessly confused everyone, let me know. But I think showing how it's basically all the servers are doing is handling a byte stream and breaking down how they see the byte stream differently, I think is probably a nicer explanation. Honestly, this is how I first understood it. So pretty much, yeah. If this is out there, you do bug bounty hunting, yeah. Yeah, so you can get some pretty decent bounties for this stuff. Cybercoach, thanks for the follow. Obviously, for all the main sites, this has been researched to death and tested to death. You can still find it. It's just rare. How often do these things get talked about? It's something that is always thought about when implementing backends, frontends. So this is the problem. Even a lot of people aren't aware of it. And it's honestly not thought about when implementing backends and front ends. However, the vendors are aware of it, so you'll probably see, especially starting 2 years ago, vendors started patching for this. They started effectively trying to mitigate this stuff. So the easiest way to mitigate it really is if there is a content length and a transfer encoding length, transfer encoding headers, to just reject the request outright. There realistically should be no client that puts both of those headers in. The other way, obviously, is there are some other ways. So the other way is always using HTTP 2 on the back end, because HTTP 2 handles this. However, that involves using HTTP 2, which nobody does. So, yeah. But honestly, there aren't many good ways of fixing this. This will happen if you have servers which respond differently, and unfortunately you do, because again, there is a standard which says if there's two headers, these two headers exist, you ignore this one and you always go with the content length. But nobody follows standards, so yeah. Yeah, if both headers are accepted, certainly probe further. The easiest way to find them is using the Request Smuggler extension. There are some scripts, I believe. You can probably find them on GitHub. Oh, Ang said you need to patch this. Yeah, you definitely need to patch this. Because even if you aren't able to do some fun smuggling stuff like save requests as comments, you can still potentially denial of service everything by just sending invalid requests that are smuggled. Yeah, you could potentially catch it in IDS. You'd have to see if there's a rule. I mean, the easiest rule would be detecting these two headers together. Dagger778 FDS101, thank you for the follow. Cool. So I guess, I mean, technically we did this one. I haven't solved it because there's technically a user in the lab who's basically, I guess, sending a request every few minutes. But as far as I'm concerned, I saved my own request. I'm pretty sure this was them, actually. Yeah, Linux. So all I did was actually, I guess, do we have to... I guess we can do it because all we need to do is save the victim's cookies. So what I'll do is I'll up this to 400 and we'll send it and see what happens. We basically need to wait. What we'll do is we'll wait for a bit. And then we'll refresh this page, and then hopefully, I don't know when it says. Oh, every few post requests that you make to the lab, the victim user will make their own request. Okay. So, I guess we can just keep sending it. And then see. Back to the blog. They're using a Linux agent, so that one didn't work. I guess we'll keep sending it. Okay, I think that worked. Linux, nope. We'll just send it a few times. Bad request to. I'll put this up. Yeah, I mean, all I need to do is send it enough times to trigger whoever the person is. Let's see. Do we have another Linux? Not yet. So we got it by accident last time. All right, let's send it one more time, and we'll wait and see. Too big to flail. Nice. Welcome. We're trying to steal this victim's cookie, and we will do it. We have a proof of concept. We've stolen our own cookies. These are all our own cookies. This is definitely all me, isn't it? Yeah. Oh, actually, is this... Oh, no, yeah, it's just a GET request. Alright, I'm going to refresh and see what happens. Okay, that might have been it. No. Every few post requests that you make to the lab, the victim will make your own. Well, they're not. I'm just going to keep sending it. Send it every few seconds and see what happens, I guess. Alright. Refresh. Oh, here we go. Hang on. Okay, there it is. So we definitely need more more content length. Alright, so let's set to 600, see what happens. Alright. I think I actually know when to determine it, because it's if you notice, it's iterating. The first time it's a 200, second time it's a 302, third time it's a 400. We covered why that was earlier. So I think if I send it and it doesn't go out of that line, I think it's... So for instance, we send it now and we don't get a 200, I think it's the victim has done it. So that should be a bad request. Yeah, that's fine. I think, let's try. Yeah, okay. Well, we'll just keep sending it until we get one out of order. So 200. Okay, see that? We got two 200s in a row. I think that means it worked. Yeah, I mean, at least it should. Yes, look. Linux 3. Okay, we need more though. Okay, I'm gonna Let's bump it up to 800, I guess. All right, here we go. 200, 302, 200. Okay, that was unexpected. We should have got a 400 there. Now it's going to mess up, I think. Okay. Okay, maybe not. Are we getting our cookie? I think the cookie should be in there. All right. So let's do it again. We get a 200. We get a 302. We get a 200. That's not a 400. So a 40, whatever it was. So I'm hoping we may need to refresh it a couple of times. No, it's just not working now. Alright, I'm just going to spam it again. This is how annoying this is. It's going to wait until we get two 200s in a row, I think. That seems to be the best indicator. We're going to have a lot of comments on this blog post. It doesn't matter. It's just that this text says every few post requests that you make, the victim user will make their own request. So usually you can just send one, and then the next time the victim loads the page, it will work. In this case, I have no idea how often I need to send this for it to trigger a post request. I don't know why they just don't have a user every 10 seconds doing something, to be honest with you. I'm just gonna... I know it's tempting fate, but I'm just gonna refresh and see what happens. No, we still have... Ah! We got 2 in a row. And that's promising. And to reload it. I'm really hoping... Yeah, we've got 4. There we go. Okay. I'm hoping... that looks like maybe... Alright, I tell you what. I hope that was enough. Let's do it. Let's get this, go to repeater, append cookie, render it. I don't think that worked. I guess I could... What was the actual... Use the victim's cookies to access their account. Yeah. I really hope that wasn't 400 bytes there. Oh, yeah, because that shouldn't be. How many characters is that? Oh, it could be because of the... Alright. Here we go again. Yeah, I think I might give up because at this point it's like, you know, I've done it 4 times. We got most of his session cookie. I am not left out. It's just you have to, when you're doing this, you have to tell it how much you want to capture. And I think originally we told it 400. We increased to 800. At 800 we got this request, which looked like it had all the cookies, but I have a suspicious feeling there's another cookie here. I mean, I guess what we could do is just put this cookie there. I don't think this is gonna work, but I mean we can try it. Maybe it worked. No. I mean, I guess we could technically just brute force it, like you said. This is the one, right? Hang on. Right. No, why is that? All right. All right. Send this to Intruder. What are these? It's basically the entire alphabet, uppercase, lowercase, and numbers. Fantastic. Simple list. A to Z, 0 to 9. So we want to do is search for login, I guess, or do a negative search for login. Oh, I think we just we just brute forced it. It was a J. Well, that's one way of doing it. If I put that in there and refresh, we're locked in. All right, who suggested brute forcing it? I forget who suggested it. Ang, thank you so much. Okay, just that's not how you solve this loud, by the way. But yeah, we turns out we only needed literally one more character. Oh man, that was funny. Perfect. I can't believe that worked on the first try. If it had like failed and I had to do 2 characters, it would have been most amusing. But luckily, okay. Let's go back down the follow list. Who haven't I seen? All right. Sancelia Osu. Again, apologies. Most of my stream is mispronouncing people's names. Kaiser Menschk, I think. I'm guessing. I don't know how you pronounce that name actually. Is it Mouse Z? Marvel Hoax and Nexinity. All right. Thank you very much, by the way, for watching. I'm gonna shove the stream ending on it. Just Mouse. All right. Hey, Mouse. Thank you so much for watching, guys, and thank you so much for the raid. That was definitely totally unexpected. Made my evening. On the screen, you can see various places to follow me. My Twitter. I have a Discord server. Obviously YouTube and If you haven't followed me on Twitch and you're still watching, give me a follow on Twitch. All right, guys. I hope everyone has a great evening. Thank you very much again for watching. Take care.